Hi, I'm Peter Scornia, president of Bazzani Building Company, and we're just finishing up a renovation and restoration of the Kingsley building here in Easttown, Grand Rapids, Michigan. Bazzani Building Company, we're a developer and design build contractor based here in Grand Rapids. We're just a couple of blocks away from this location. Started by a guy Bazzani in the 80s, and he's had a big part of renovating and restoring this side of town in Grand Rapids with a focus on sustainable design. We are a B Corp, which celebrates the triple bottom line of focusing on profit, people, and planet for our projects. The Kingsley building, we're pursuing gold LEED certification using LEED for homes. This is primarily a residential project. We have 41 new 1- and 2-bedroom apartments on the upper 3 floors of the building. And then we have about 22 offices and storage rooms, and we also added about 65 parking spaces. The Kingsley building was built as a storage building in 1926, and at the time, what you needed in storage was big open footprints and a building that's fireproof. So all concrete construction, brick exterior, very few windows. The windows were very small, and they actually had, it was an interesting design at the time, a fusible link on them that in case of fire, the windows would slam shut and seal off the building and cut off any air supply. Great at the time for a storage building. And the concrete construction and the brick exterior is fantastic for a long life cycle building, and we were able to reuse all of that. What didn't work from converting this to residential use was the small number of windows, no natural daylight in from the exterior of the building, and the large footprint, no daylight at all in the center of the building. So what we did from a design standpoint to accommodate that was add lots of new windows on the outside, thermally efficient windows, and patios with a small balcony. And then in the center of the building, which wouldn't be usable as living space, we added skylights on the roof and then cut out sections of the floor so that we have an atrium, and that gets light deep into the space. And then for bedrooms that are on the interior, those bedrooms have windows that go out into the interior of the space so they get the natural light coming through from the skylight. And that allowed us to get more units into the building by making them a little narrower. So you have one bedroom that's on an outside wall, the living rooms that are on an outside wall, and then an interior bedroom on the 2-bedroom units. One of the great things about starting with an existing building that is concrete is that the structure was in good shape. We had a little bit of repair to do in the basement, but really small relative to the overall size of the project. So we're able to reuse all of that structure and the exterior. And then when we cut in new windows, we saved all of that brick, and we're able to clean that, reuse it for infill in areas that needed to be patched on the exterior. And then cutting out large sections of the floor on the inside, all of that concrete was recycled. So from a LEED standpoint of tracking recycling, the reuse and recycling was scored very high because of the components of the existing building. For a renovation project, it can take as long or longer than building a new building because you have to deal with all of the issues associated with an existing building. And this one had its own challenges because we were working on the top 4 floors of a 5-story building where the first floor was occupied. And it's a tight site. We used every inch of the site with putting in a new parking ramp and doing excavating down into the basement with residential on one side and the existing building and commercial on the other side. So those aspects of renovating an existing building in the city, you certainly bring their challenges. It's just some fun things about working in an old building and seeing how it was done, and in a building that's 80 years old. It was built as a storage building. One of the things when we were initially getting in and starting with the demolition process, we found a letter from 1903, I think, that was a letter that a woman who lived here in Grand Rapids had written home to her parents in Iowa, and talking about life in Grand Rapids at the time. And just a fun part of working in an old building. and then the building itself, how it was designed and how it was used. It had a coal-fired furnace when it was built down in the basement. It had a giant boiler room in the basement that now is the elevator lobby. All of that was taken out and cleaning all of the coal dust off of the walls and out of the basement, and how those mechanical electrical systems and things have changed so much since then. The room that we're standing in is a bedroom on the 5th floor, and in the background is a clock that was original to the building, that was designed by Art Kingsley, who the building is named after. He was the architect for it, and he always put a feature into his building that really had an architectural appeal, even though it was just a storage building. It was a beautiful building for the time, and we definitely wanted to maintain the clock. But from the inside, there wasn't much to it. You were just looking at the back of a clock. So we incorporated it into the design. We took the glass out of the center and replaced it with clear glass, and then built the enclosure around, put another layer of glass on the inside so it doesn't leak, so you don't have drafts coming through. And then added a blind so people can close it at night. But it's a beautiful view of the city looking up Lake Drive. When we were getting set up for the interview today, Brett and I ran into somebody coming off the elevator, and she'd moved in almost a month ago now, and she commented again about how much she loved the building. And I think there are a lot of features that go in that people don't realize or couldn't see when it was a storage building and couldn't imagine living in that space. But to come in now, they love it. And a friend of mine that I work with has a great quote of that, of going through a renovated space, and they say, "I don't know why I love it, but I love it." And they may not know, and I'm sure they don't know, all of the details that went in figuring out of how to use an existing space. How can you convert this? How do you take advantage of the structure and the beauty of the building, and work with all of the quirks to it to make it an energy efficient modern building that'll make it last another 100 years. Yeah, so this is a market rate project, and we have support from the BD+C and from the Brownfield Redevelopment Authority that provided assistance for the addition of the parking structure. From a stormwater management plan for the Kingsley project, we have an advantage of being in a very sandy soil area, which is great for building on, and then great for site drainage. So we're a zero stormwater discharge site, and have a leach basin in the parking lot, and then all of the water is collected and just goes right into the soil. And from a landscaping standpoint, with the addition of the parking structure, which can be not always the most attractive things to put into a residential neighborhood, we put vines around the outside that'll grow up and cover the parking structure, and then also tilted it so it's mostly buried underground, and have had a very positive reaction from the neighbors once it was put in, of how that fit into the neighborhood. Working with the existing building, it was just brick, and 3 whites of brick, so you have a good layer there, but really no insulation value to it whatsoever. The roof had been, we had a new roof put on 4 or 5 years ago, so we had a good R value on the roof, but nothing on the walls, and a brick wall like that is going to leak. You're going to get air coming through it. So for putting apartments in, what we did was spray foam insulation, so we get a great R value on the exterior wall, and also helps with compartmentalization of the apartments because it seals it up tight. And then the adjacent walls between the apartments, we did a double wall, so you have a separation between each of the units. That helps with air sealing of the units, as well as sound control. So you have great acoustics from one unit to the next. During the construction process, we of course have the inspection process through LEED, and then once that's complete and the units are done, we have the doors on, we come in and do a blower door test. And the results actually came back so positive on that, we were able to go back and improve on the energy model from the original assumptions that were made that helped with our energy score. Another challenge of working with an existing building, you cannot change the ceiling heights, you can't change anything about the structure. So we were limited in how much ductwork we could use without having it really inhibit the space. And we wanted to leave as much of the structure exposed, beautiful old style of concrete at the time that was done before plywood. So it was, you have the exposed wood plank look that you get with having exposed concrete, and we wanted to maintain that, but minimize the amount of new ductwork size that was coming in. What we ended up doing on the HVAC system was the variable refrigerant flow, and what that allows us to do is run a lot of copper pipe, but that's really small. Can be run in the chases above the ceilings and such, and a relatively small amount of ductwork. Most of the air distribution happens within the apartment itself, and then we used an energy recovery system, so the exhaust air that comes out of the kitchens and the bathrooms all goes up, is collected, goes up to the roof, goes through the ERV system in exchange for the fresh air coming in, and then that fresh air that comes into the apartment. And that kept the ductwork size much smaller. That was able to be done all outside of the units. So with the challenges of the floor-to-floor and trying to minimize the amount of ductwork by using the ERV system, we have the exhaust coming out of the bathrooms and kitchens. That doesn't go directly outside from the apartment. And what that helps with is keeping the apartment really tight, and helps with that compartmentalization. And also we did all electric. We have electric ranges and electric dryers, so we don't have gas coming into the apartments. And we did ventless dryers, so that also minimized the amount of ductwork. VRFs are becoming pretty popular. We looked at a few different systems. We did look at geothermal. The site wasn't ideal for it, and we just couldn't get the numbers to work with that sandy soil. We got the energy model process started right away, and that is really what led us to the VRF. That was able to show that we'd get pretty efficient savings by using that system, as well as the advantages of minimizing the amount of ductwork. There were a few concerns about it in a cold weather climate. It's relatively new for that. So the things we did to offset that were the ERV. So we're preheating the air using the energy from the exhaust, and cooling it as well in the summertime. And then we also added a gas preheat that's up on the rooftop. So we do have gas to the building for the preheat system on the ERV. In doing apartments, one of the things that we have to look at as developers at the beginning of the project is how does it function in the pro forma? What are the utility expenses going to be for the landlord and for the tenants? And in a typical system where the tenant has a furnace in their unit with gas to it and a compressor, they pay all of the utility bills. And you can, by providing a good tight thermal envelope, by putting in energy efficient windows, doing spray foam insulation, and getting a good envelope, you can reduce those utility costs for the tenants, but ultimately that's the responsibility of the tenant. With the VRF system, we have a smaller number of condensers on the roof with a refrigerant that's cycled around, but that can't be individually appropriated to each tenant. So the heating and cooling costs become a landlord expense rather than a tenant expense. So the energy model was very important for us at the beginning of the project when we were putting the pro forma together, to know how much to plan on for landlord utility expenses, and being able to know that up front and then figure that in to the rent appropriately. For the tenants in the building, it means that they're essentially not having to pay for heating and cooling. The system is efficient that if you have one person calling for heating and one person calling for cooling, the VRF system exchanges those two. So it reduces the mechanical heating or cooling that are added into the system by balancing between them. With the energy model, we were able to predict at the beginning what the utility expenses will be. And then during construction, once that system is done, we have a commissioning agent that works with us, taking from the energy model and the plans and specifications for the project to make sure that it's installed correctly and will operate the way that it's expected to with the energy model. And it's a great process for bringing in an independent third-party verifier, in addition to what we use for the LEED for homes process, that really gets in and understands how the system works and can evaluate the installation all the way through, and then the testing and verification at the end of it. And then with that, with the energy model, then a year, 2 years, 3 years into operation, you can look back and have something to compare to see how you're doing against it. For interior finishes, low VOC paint, and we did vinyl flooring, and that's become typical for us, and I think fairly typical for, certainly for contractors that are doing LEED certified buildings now. And that's been a big improvement over the last, going on over 15 years now that LEED has been in existence, that these systems are becoming commonplace, and subcontractors are familiar with them. They've used them. I think that applies to materials, it applies to recycling, waste reduction. It has become for us common practice, and it's just how we work now. For water conservation, that applies to the toilets. We have the dual flush toilets, the showers, low flow on the showers, and the washers. So the Kingsley building, located here in East Town, great access to lots of local restaurants and entertainment. The city of Grand Rapids has been promoting a more walkable city, and this project was perfect for it because it's an existing building located in the center of the city with lots of things going on around it. We did add parking spaces. We're not quite there yet with everybody being able to walk, but there are a number of things in the neighborhood. And also the first floor is retail that was already occupied. The first floor was renovated 4 or 5 years ago, and there's a restaurant, a butcher, a baker, and a fitness studio on the first floor. We're excited about completing the project. We have 41 new apartments, 20 of which are already occupied, and most of them are already leased. We have other residential projects coming up in the future in the Grand Rapids area. And for more information on the project, go to our website, Bazzani.com, and we'll have links to the Kingsley building as well as other LEED projects that we have done.
Well, thanks for joining us, and a big thanks to our volunteers, our board of directors, our members, and our sponsors who allow us to do what we do. A huge thanks to our top sponsors, T-Stud, who make insulated studs that help save energy and money in the walls, and Shrinergy, who have microgrid solutions and portable battery and solar solutions for emergency issues, for travel, and for backup energy and saving energy at home. Check them out. And make sure to go to our website, greenhomeinstitute.org. Again, check out all of our videos and upcoming session and live webinar events. Thank you.